Welcome back, ladies and gentlemen, to Physical Science with Mr. Kenton. I know your favorite teacher. You're just so excited that I keep putting out these videos. I know. Try to contain your excitement. All right. And we're going to continue to talk about the structure of the atom by introducing something a little bit different. We've been dealing with atoms and isotopes, and atoms and isotopes are both neutral, electrically neutral. So that means that the number of protons and the number of electrons are the same in atoms and isotopes. However, there are instances where atoms have different numbers of protons and electrons, and so at that point they're no longer atoms, but now they're ions, okay? And so I'm going to talk to you guys a bit about ions and what we need to be able to know about those. So as you can see here, an ion is a particle that gets formed when elements react by losing or gaining electrons. So that means that in order for an ion to form, the atom has to either gain an electron or it has to lose an electron, okay? Now, again, just as a reminder, at this point, we've only been looking at atoms and isotopes, which are electrically neutral, right? And so with these ions, this is where we start to get into and understanding chemical reactions. This is where chemical reactions come into play, because as those electrons are lost and gained, it changes the properties of the atom and allows it to form essentially a new substance, okay? Now, our ions are going to fall into two categories. We've got what are known as cations and anions, okay? And again, that's cations. It's not cations. I know you were thinking it, but those are cations and anions. Those are not anions. I know you're also thinking that. Anions, okay? So we've got these ions. Let's talk about each of those two different categories. We're going to start first with those cations. Now, a cation is a positively charged ion. Now, in order for a cation to form, in order for it to be positively charged, that means that your atom needs to lose electrons. So anytime an atom loses electrons, we're going to refer to it as a cation. Now, if it loses electrons, I want you to think about this in terms of our protons and our electrons. If I'm losing an electron in a cation, that means that the number of protons is going to be greater than the number of electrons that are now in this particular ion. Okay, so cations have a greater number of protons than electrons. And to designate that an atom has lost electrons, what chemists will do and what we will do is that when we write out the symbol of our element, we're going to put as a superscript to the right of that element symbol, we're going to write the charge of that particular element. Now, or I guess in this case, no longer an element, it is a cation, okay? Now, the next slide gives us a specific example of what this is going to look like. So here's our example. If you look over to the left, you've got this 27Al3+, okay? Now, the 27, remember, that's the mass number. Al, that's the chemical symbol. And then you've got that 3+. So the Al tells us the symbol, that's actually aluminum, right? 27 is the mass number. And then in this particular case, we're saying that this aluminum ion has a 3+ charge. Now, what does that 3+ charge tell us in terms of our subatomic particles that make up this ion? So we'd have to look on the periodic table, find aluminum. Its atomic number is 13. So that means that aluminum has 13 protons, okay? In terms of the electrons now, this is where things get a little bit different. I want you to focus in here. So we said that aluminum has a 3+ charge, and we said that when it's a positive, the number of protons outnumbers the number of electrons. So then I've got my 13, which is the amount of electrons I would normally have for aluminum. And I'm going to take that charge, because it's positive, and I'm going to subtract that from my number of electrons that I have in total. So 13 minus 3, that means that my aluminum ion, my aluminum cation, has a total of 10 electrons. That makes sense? So 13 minus 3 gives me a total of 10 electrons in my aluminum cation. And then I've shown you also the number of neutrons. You take the mass number, subtract the atomic number, and you get 14 for the number of neutrons in this cation of aluminum. Now, just as a recap, since aluminum is positively charged, it must have more protons than electrons, okay? Now, moving on, we're going to look at anions now. So anions are going to be negatively charged ions. They get formed when an atom gains additional electrons through some sort of chemical process. So that means that our atom is going to get additional electrons added to its electron cloud. Okay? And just thinking about what's going on now in terms of the subatomic particles, if you have an anion that's negatively charged, it's gained additional electrons, that means that the number of protons will always be less than the number of electrons in our anions, okay? Notice the difference here between cations and anions. Anions have less protons than electrons, okay? Let's look at our example of what that would look like, okay? And so what I've given you guys here is an anion of oxygen. Again, on the left, you've got your symbol, you've got your 16, that's your mass number. You've got your element symbol O, which is letting us know that we have oxygen. And then here's our superscript with our charge. It's got a 2 and a minus sign. So that minus sign is letting us know that it's negatively charged. Now, what's going on with the number of protons, electrons, and neutrons here? So in this example, we've got 8 protons, because we look at the periodic table, we find oxygen, and its atomic number is 8. Okay, so its number of protons is 8. Now, when we want to figure out our number of electrons, notice there's a slight difference here. We're going to start with how many we would normally have in a neutral atom, which is 8. Now, because it's a -2 charge, we're going to add that charge to our number of electrons. So there's that 2. That means we're going to do 8 plus 2. So that means that in that oxygen anion, it has 10 electrons, total of 10 electrons. Okay. And for our neutrons, that's how we calculate using mass number. We take the 16, subtract the number of protons from it. 16 minus 8 is 8. That's how many neutrons we have. Now again, notice that the number of protons in an anion, specifically in this anion and all other anions, the number of protons is less than the number of electrons. Okay? Now, here is a summary of all of the particle changes we have been looking at as we've been learning about the atomic structure, isotopes, ions, and atoms, okay? And so just a quick summary here. If you change the number of protons that an atom has, you are going to change the identity of the element. The result that you get when changing protons, you now have a different element on the periodic table. If you change the number of neutrons, okay, so you add or remove neutrons from the nucleus, but you keep the protons and electrons the same, you end up with a different isotope of the same element. And then lastly, if we change the number of electrons that an atom has, right? Assuming we're keeping protons and neutrons the same here. We change the number of electrons, and then we get a different ion of that particular substance, okay? Hope that was useful. If there's something you didn't catch, go back and watch the video, and hopefully that'll help clarify some things. Thanks for joining me, and I'll see you guys soon.